Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe, and I'm going to be hosting today's session, which is a masterclass focusing on a deep dive on Amazon EC2. We have another webinar series called The Journey Through the Cloud. You can find the series page for this in the links panel in the webinar interface, or in the webinar description, the video description, if you're watching this on YouTube on demand. And that's a solutions-orientated look at how you can apply a variety of different AWS services to a particular set of usage scenarios or challenges that you might face in your organization. So check out that other set of webinars if you're interested in taking a look at AWS services from that perspective. Today we're on a masterclass, which means a deep dive into one specific AWS service, and we're covering EC2 today. We have a lot of material in today's session. Lots of the slides that we're going to be using have things embedded in them where you can find further information about the topics we're going to be covering. And if you want to make your life a little bit easier, you can download the materials from today's session. Once again, in the files panel in the webinar interface, you'll find a place where you can download a PDF of today's slides. And if you're watching on YouTube, once again, there's a link in the video description to SlideShare, where you can also download a PDF of the materials from today's session, or just review them online and access those links, which I think you'll find helpful. If there's stuff that we don't cover during today's session or topics that you want to know more about, please ask us a question using the Q&A panel. Once again, that's visible in the webinar interface. And a member of our team will get back to you after the webinar. We'll try to come to some of these questions at the end of today's session, but we do have a lot of content today. EC2 is a very expansive service, a lot of topics to cover, so we maybe have difficulty fitting everything inside the hour. So with that in mind, we're going to get on in a second with the content. Just one other thing to say, which is at the end of the session, I'm going to do a couple of things. I'm going to put the webinar into Q&A mode, which will give you an opportunity to give us some feedback, and I'd like you to spend a couple of minutes just to give us a rating between 1 and 5, with 5 being the best. Let us know how well we've met your expectations today. And of course, if you've got qualitative feedback that you want to leave for us, we'd really welcome that via the Q&A interface, via that Q&A panel as well. If you think there are things we could improve upon for this webinar for the next time we run it, please let us know about that. You'll also see some social media links at the end of the session, in addition to my Twitter, which you can see on the screen right now. And if you can follow us on the social media links that we show at the end, you'll have a good opportunity then to stay up to date with AWS and also continue to stay up to date with our education program in the English language here in the European time zone. So follow us on social media at the end of the session. Of course, you can find me on Twitter as well. Okay, that's a little bit of housekeeping out of the way. Let's get on with today's session, a masterclass looking at Amazon EC2. And these masterclass series webinars, well, they're intended to be a technical deep dive that goes well beyond the basics of one individual AWS service, helping to educate you on how you can get the best out of the service upon which we're focusing, and show you how things work and how you can get things done using a variety of different interfaces to control and manage AWS services. And the focus for today's session, as we've already said quite a few times, is Amazon EC2, so the Elastic Compute Cloud, providing resizable compute capacity in the AWS cloud. And this service is designed to make web-scale cloud computing much, much easier, offering a true virtual computing environment, enabling you to launch instances with a wide variety of different operating systems, and of course to run as many or as few systems, as many or as few instances as you desire. The basic characteristics of the service, well, elasticity, so it enables you to increase or decrease capacity in minutes, not hours or days, and you can commission hundreds or thousands of servers simultaneously. And we've got good examples of customers operating on EC2 at really high scale. Everything's controlled with those familiar AWS Web Services APIs. This means that your application can automatically scale itself up or down depending on its own needs. And those APIs offer complete control of your instances, but we also provide full root access or administrator access to each instance that you're running, meaning that you can interact with those instances just as you would any other machine, any other system that you might be managing. You're able to stop and start your instances while retaining data, and then you can subsequently rehydrate or unhibernate those instances and bring them back into service. And of course, you have the ability to restart or reboot instances using the Web Services APIs, and you have console output access to your instances as well. It's flexible, giving you multiple different instance types, which we'll cover in more detail later, as well as a variety of different operating system types and software packages. That scalability and reliability of the platform is also very important. The fact that there's a reliable platform there where instances can be replaced if necessary, rapidly and predictably commissioned. It's secure, working in conjunction with Amazon's Virtual Private Cloud, or VPC, something we're going to cover in much more detail later on in today's session. It's inexpensive with the familiar on-demand billing model with no upfront commitments, allowing you to pay for compute capacity by the hour. And it's easy to start, and we'll show you during the session today just how easy it is to get started with EC2 using either Amazon Machine Images or the AWS Marketplace, where you can find a very wide variety of pre-configured software for use on the EC2 service. That's a quick overview of some of the benefits. I normally have a slide here which has a variety of different use cases on it, but for EC2 it's somewhat tricky to do that, and I think rather than trying to flood this slide with different potential use cases for EC2, I'll just say that the use cases for EC2 are any software which runs on a supported operating system. So any use case that you can put a compute resource to is a use case that can be fulfilled by the EC2 service. So there's not a lot more that you can say beyond that, just that you can do just about anything that you can do with a computer with the EC2 platform, with the EC2 service. I want to say something quickly about the history of EC2. It's a service that's been around for a long time, and I doubt very much that when my colleague Jeff Barr wrote this post back in August 2006 that he thought his holiday pictures would feature in a webinar now in the middle of 2015. But it's an interesting post to go back through the AWS blog archives and take a look at, because you can see that the EC2 service started with very humble beginnings. We offered a single virtual CPU, a 1.7 equivalent to a 1.7 gigahertz Xeon, 1.75 gigs of RAM, and 160 gigabytes of local disk space. This was billed at 10 cents per clock hour. So we're talking about the mists of time, really, and you'll see over the course of the session that a lot of depth and a lot of breadth has been added to the EC2 feature set over that period. But we've been operating EC2 for a long time, and as a result of that, we've got a very well evolved service, which is very well understood and has some very powerful characteristics for developers today. So thanks to Jeff for his original launch post back in 2006. The evolution of the service continues, if anything, at an accelerating pace today. And we've added a lot of features over the course of even the last few months. Here you can see an extract of AWS compute-related service announcements from the latter period of 2014 and the early part of 2015. And you can see that we're enhancing the service, launching both enhancements to the EC2 core service, as well as evolving the way in which computing services can be delivered in the AWS cloud. And we'll come back to touch upon a few of these new innovations later in the session. Before we do that, let's take a look at the agenda and get into the meat of today's webinar. So what are we going to be covering today? We're going to be taking a look at EC2 concepts and fundamentals, storage and networking, monitoring, metrics and logs, security and access control, deployment and cost optimization techniques. And there is a lot to cover today, which means that some of these topics aren't going to be covered in the same depth they might normally be covered in another masterclass webinar, because there's simply so much breadth to go out with this service. So, EC2 concepts. Importantly, EC2 is organized into AWS's regions around the world. These are geographical locations where EC2 will launch the instances that you create. You can choose a region, should choose a region really, to optimize latency, minimize costs, or address specific regulatory requirements you might have for data placement. We currently have 11 AWS regions around the world, and it's important to make a distinction. There's still confusion about this, unfortunately. A region does not equate to a data center. A region comprises multiple availability zones, and each of these availability zones contains 1 to 6 data centers, depending on where you go in the world and precisely how big the region is in terms of scale. So the availability zones themselves, each of which, as I've said, comprises multiple data centers, those are distinct locations that are engineered to be insulated from failures in other availability zones, or AZs. They also provide inexpensive and low latency connectivity to other availability zones in the same region. And those 11 regions that we have around the world contain between 2 and 5 EC2 availability zones. Here in Europe, we have 3 AZs or availability zones in our Dublin, Ireland region and 2 in our Frankfurt, Germany region. When you wish to launch an EC2 instance, you'll place that in one of those availability zones. And we provide a wide selection of different instance types that are optimized for different use cases. And this, when I say different types, I'm talking here about varying combinations of CPU, memory storage, and networking capacity. And in the case of one particular instance family, the provision of NVIDIA floating point GPU units inside the instances as well that you're able to access. So that's a little bit about fundamentals in terms of the logical construct of regions, AZs, and of course instances themselves. Next thing we're going to do is take a look at some of the fundamentals of EC2. The first is that EC2 is available, as we've already mentioned actually, in several different locations around the world. These are called regions, as we've mentioned. And if you check out the URL that you can see at the bottom of the page here, you can find always up-to-date information about the regions that EC2 is available in, as well as details of things like how many availability zones there are in each region, and also information about which specific instance types are available in which regions. There's an extensive list of supported operating systems and software, both operating systems that you can see listed here and find out more information about those in the EC2 frequently asked questions, as well as commercially packaged software which is made available either under bring your own licensing schemes from ISVs or in the AWS marketplace, where you're able to purchase and deploy commercial software and also deploy open source software directly onto the EC2 platform through a simple one-click installation process. So if you're interested in running commercial software on the AWS platform, I'd say check out the marketplace. It may be possible for you to license your commercial software by the hour in the same way that you pay for your EC2 resources. If you're not familiar with it, it's something that it's well worth learning a bit about. There's integration between AWS, other AWS services and EC2. In the course of this session, we're going to cover the Elastic Block Store, EBS, CloudWatch, VPC, and AWS IAM, or Identity and Access Management. But there are also other AWS services that are built on top of the EC2 platform. It's quite interesting. If you look at Amazon Elastic MapReduce, our Hadoop service, for example, when you create an EMR cluster, you're creating a group of EC2 instances which have various roles within that cluster. And EC2 is a service that we use ourselves as the foundation for many other things that we do. And there is strong service integration between EC2 and other AWS services. There are also purchasing options. We'll return to this in more detail at the end of today's session. But there are several different ways in which you can optimize your cost with EC2. You can also import and export virtual machines in other formats. You may have VMware or Microsoft Azure virtual machines that you wish to bring in to Amazon Web Services to run on the Amazon EC2 service. You can do that with our VM import service, and you can find out more details about the process for that at the bottom of the URL you can see at the bottom of this slide. And then lastly, instance formats, instance types. There are a variety of different instance types available to you that are serviced with resources in different ratios, whether that's the M4, the general purpose balanced CPU and RAM instances, or the GPU optimized G2, which gives access to an NVIDIA Kepler floating point unit, or whether it's the latest generation of C4 compute optimized instance. You can optimize the instance that you use to match your workload, and more importantly perhaps, instances that are optimized offer their optimized resources at the best price point. So a gigabyte of RAM will cost less in an R3 than in any other instance type. A CPU cycle will cost less in a C4, and so on. So you should choose your instance type in order to optimize for performance and for cost. And when we have instances, we denote them in this format. So the generation, the type, so the size, and the family. And there's a couple of these specific types and families that I want to talk about now. First of all, the T2. This is a low-cost EC2 instance with burstable performance. And what happens with the T2 is that you're allocated a baseline performance level, but the instances also accrue CPU credits, and you can deplete these CPU credits for improved CPU performance over a period of time. Okay, so baseline performance, say the T2 small, it's receiving credits at a rate of 12 CPU credits per hour. and it provides baseline performance equivalent to 20% of a CPU core. If at any moment the instance does not need those credits, it stores them in a CPU credit balance for up to 24 hours, and then when your T2 small needs to burst to a level more than 20% of a CPU core, it draws down from that CPU credit balance to handle that surge seamlessly. Over time, if your workload depletes all the CPU credits that you have and you don't maintain a positive credit balance, you'll be capped to that 20% of a CPU core, and maybe then it's time to upgrade to either a larger T2 or to a fixed performance instance type. But it actually fits very well for applications that need burst performance, which is actually a significant percentage of many different types of apps. So you can take a look at that maybe as a first target when you're testing or piloting and establishing whether that offers a good platform upon which for you to run your apps. At the other end of the spectrum, to some extent, is the C4 instances. These are the highest performing compute instances that Amazon EC2 has ever provided. We're making use here of the Intel Haswell Xeon V3 processors, and we're exposing advanced features from the processor such as the AEX2 enhanced vector extensions, and also we're offering an instance here with 36 of these Intel Haswell cores made available to you together with 60 gigs of RAM in the C4AX large. So a very good instance for running compute intensive or high performance workloads. So next we're going to move on and talk quickly about the life cycle of an instance. So when starting an EC2 instance, you have a variety of different options that you can use to launch an instance using console, CLI tools, or AWS SDKs. And we're going to cover these in more detail later in the session. You then configure your instance using either an AWS Army, an Amazon machine image, which is the baseline from which your image will be created. Or you can use automation tools, and again we're going to cover that in a little bit more detail later in today's session. One of the tools that you have for doing this configuration is a service called the EC2 Instance Metadata service. This is a private web service that's made available to each EC2 instance that you create, and it contains metadata about instance state, so things like the AMI ID, the host name, block device mappings, the kernel ID that's been run, as well as information about the network, the placement of the instance, security groups, the public host name. They're all available through this EC2 metadata service. And a guide to EC2 metadata is available at the URL that you can see at the bottom of this slide. One of the ways that you can use this is to access something called EC2 user data, which is specific data that is passed to the instance in the metadata service. And this is used by AWS provided armies, Amazon machine images, to perform instance bootstrapping actions. What happens at startup time when the instance is created? The AWS provided armies have software components on them that read the EC2 instance metadata and will execute commands that they find there. On Windows, you can use Windows scripting or PowerShell. And on Linux, you can actually use any command interpreter. But here we're showing usage of the bash shell, so shell scripting, to execute an action at creation time on a Linux instance. And we'll come back to this in a few minutes and show you how this can work in practice in a short demo. But this is actually a very powerful tool to allow you to bootstrap and configure instances at creation time using data which is passed to the instance through that instance data user metadata service. Once you've done that, you can connect to your instance using standard protocols, subject of course to having set a security policy that enables you to do so. Once again, we'll cover that in a few minutes, but you have the normal approach then for managing and controlling your instance using standard tools like SSH, RDP, or any other tool that can be carried over TCP or UDP. And then once you're done, you can terminate your instance to minimize costs. And this is important. We really like to encourage customers to think about EC2 instances as disposable commodities that can be available when you need them and then stopped when you don't need them. And obviously, sensible use of that facility of terminating or stopping instances is a really good way to optimize your costs and reduce the amount that you spend. So we really like to encourage customers to think about their compute as a disposable resource that's available on demand and use that as a mechanism for cost optimization. Again, we'll talk a little bit more about that later in the session. Okay, the next thing I want to do is show you a quick demo of getting started with EC2 on the AWS console. So let's do that right now. So here we are in the AWS console, and obviously we're going to be working with the EC2 service today. You can see also that we're operating in the Oregon region in the northwest US here today. So onto the EC2 subconsole, which we'll access just by clicking obviously on the EC2 service here. And you can see we've got an empty account here with no running instances. I've got a pre-created key pair which I'm going to use for accessing my instances later on, and I've got some security groups that I'm also going to make use of for accessing my instances as well. Obviously what we're going to do here is show you the launch process. So I'll go to launch instance, and at this point I'm taken into a wizard driven launch process which will go through the few process steps that you can see at the top of the screen here. So I'm going to launch several Amazon Linux instances by way of a demo here. So I'll select the Amazon Linux Army, and I'm going to launch several T2 mediums out of that T2 burstable performance tier. So I'm just selecting the specific type of instance that I want to launch there, and if I scroll down you can see there's all of the current instance generations and variations that are available are shown here in this list. So picking the particular instance type that I want is just as easy as picking from this list. And then go to configure my instance details. I'm going to launch 3 instances. I'm going to put them in my default VPC. What we are going to change here is we're going to use some of that instance metadata user data to automatically configure these instances for us at creation time. So I'm just going to cut and paste that from another window that I have on my other screen. And I'll paste that into the user data field that you can see at the bottom of here. And if you just review this content, you'll see that I'm executing actions on the Linux environment that's going to be installed on these instances to install Apache and a PHP environment, to turn on the Apache server, start it, and then I'm going to grab a simple piece of PHP from this location on S3, which is a publicly accessible location on S3, and I'm going to move that into a location on the instances where it can be served to deliver a piece of content just for the purposes of this demo. So next thing we would do if we were going to complete the process is add storage. We're not going to change anything here because we'll show you this a little bit later on. And then lastly, we can tag our instances with a name. So we'll put a name in here so that we can identify them easily in the console. Then we're asked to configure security groups, and these are the software firewalls that we're going to use to give us access to our instances so that we can access the content that's on them. For the time being, I'm just going to enable HTTP access, so I will not be able to log into these instances remotely. But I just want to show you that the bootstrapping actions that I've included there have concluded. You can see there we're not going to be able to connect to this instance using SSH. That's fine. Then we have an opportunity to review the configuration of our instances and then launch. We are going to set up a key pair, which I have pre-installed, as I said, which is the public-private key pair that's going to be used for SSH to these instances later on when we modify our security group. Then we go into launch instances, and you can see here that we can now view our instances in the console. So if we hit that, you'll see those are 3 new instances that are being created. You can see the name that I just typed in there, instance IDs, instance type, the availability zone that they're being launched in, the instance state. This will just take a couple of minutes now to launch these instances and get them into a state where they're ready for use. I'm going to open another browser tab and access the HTTP server on one of those 3 instances that we've created. And when we do that, you'll see that we have our very simple piece of PHP, which is actually accessing EC2 metadata itself to return information about the instances from the metadata service. So you can see that this is instance I95D7, which is the top instance in our list here. So we have in fact just created 3 different instances there. We'll go to another one of them just to illustrate that the metadata service is unique for each one of the unique instances that is running. There's the second or third instance in the list, which is I96D71. You can see corresponds to the instance ID just here. So that's a very quick demo of getting started with EC2 using the AWS console. Let's return to the slides now and continue with the webinar. Next thing I want to show you is that you have parity of control if you're using the AWS CLI. And this next couple of slides just show an annotated CLI command for creating instances via the AWS CLI. So passing in a set of parameters, including the image ID, the instance type that you want to launch, in this case it's T2 Micro, the count, the number of instances that you want to create, in this case it's 1, referencing security group IDs. Here we're using the security group IDs themselves, but you can also use security group names if you slightly change the parameter that you're using and use security-group-name instead. And then lastly, key pair that you want to use to secure access to the instances that you're creating. And if you do run that command on the CLI, here we've set the output of the command to table format using -- output table at the end of the command. You can see at the top there. And it'll return back to us data about the instances that have just been created for us as a result of that API call. And of course, you can get that output in text or JSON format if you wish to do so as well. And I don't know how familiar you are with the AWS CLI, but what I would say about it is you can get detailed help on every single AWS CLI command. So here we would have typed in AWS EC2 run-instances space help. This would return to us comprehensive help, including a command synopsis and a full list of all the different options and attributes that are available to you if you're going to use this specific CLI command. I've added a link at the bottom of the slide here to the latest command reference for EC2 within the CLI, and you'll find a similar command reference for every AWS service actually, but there's a lot of information there that makes it very easy to get started with the AWS CLI for scripting or for everyday automation of your AWS management activities. You can also control AWS EC2, Amazon EC2 via the SDKs that we provide. And here's a code sample from the brand new Python Boto 3 SDK showing the creation of an EC2 resource type and execution of the create instances method, which is going to create as an instance. And once again, we're passing in data. Here we're actually creating exactly the same thing that we created a second ago. Same army, same instance type, slightly different key pair names, same security groups, and that'll return back to us value for the object, which is the instance ID that we've created. And then you can use this instances filter to terminate instances by instance ID, so immediately shut down that instance. And once again, we're returned status information indicating that has returned a 200 code and the status is in shutting down status. So it's very simple to work with EC2 using these SDKs. I've shown you the Boto 3 there, but there's a variety of different SDKs available, as I'm sure you know. So that's getting started with a variety of different control options for EC2. Let's move on now and take a look at instance storage, or storage more generally to be precise. And there are a couple of different storage options that are available to you when you're making use of EC2. The first is what I just said, instance storage, which is ephemeral storage within the host computers that run your instances. And then you have Amazon EBS, the Elastic Block Store. It's network attached block devices. And that's integrated with S3 for snapshotting. So if you take a snapshot off an EBS volume, that'll be stored with the familiar durability and regional specificity that you have with the S3 service. It's worthwhile just digging into these two options, instance storage and EBS, in a little bit more detail. So instance storage, as I said, physically attached to the host computer. Type and amount varies by instance type, and you can find more information about instance storage by specific instance type on the EC2 instances page on the AWS website. And data here is dependent on instance life cycle. Contrast that with EBS, where you've got persistent block level storage volumes that are attached over a network, available in a variety of different options: magnetic, general purpose SSD, or provisioned IOPS SSD. And in this case, your data is independent of the instance lifecycle. So EBS volumes can and do survive instance stop-start and termination actions. This is in contrast again to instance stores. Data is lost if the underlying instance drive fails, an EBS-backed instance is stopped, or the instance is terminated. In the case of instance storage volumes, they do persist through a reboot, but they don't persist through stop-start or termination actions. That's very important to understand. There are situations where you would still use instance storage because they are locally attached, physically attached to the host computer. So they offer excellent performance, and they also offer performance without I/O restrictions. So you can drive them to the I/O limit without any additional charges becoming applicable to your account, which is important for certain types of workload, but they shouldn't be used for situations where they are the only persistence mechanism for data which needs to be persisted, because that will invariably lead to issues down track. EBS is a much better solution for that persistent data use case. Here we're replicating volumes automatically within the availability zone, so we're providing for good durability of volumes, and you can use them in conjunction with EBS optimized instances to deliver dedicated throughput between EC2 and EBS volumes. There are options there for between 500 megabytes per second and 4,000 megabytes per second, depending on your instance type. So you can drive really significant performance through these EBS optimized instances in conjunction with EBS volumes. And the lifecycle, again, is something which you need to know about. So EBS volumes attached to a running instance automatically detach from that instance with data intact when the instance is terminated. EBS volumes created and attached to an instance at launch are normally deleted unless you modify the behavior of those volumes by changing the value of the flag delete on termination. So you can set your EBS volumes to auto persist by changing the delete on termination flag. This can help with persistence, and it just indicates that data is independent of instance lifecycle. As I said a second ago, EBS snapshots are integrated with S3, so it's a point-in-time backup copy of an EBS volume which is stored on S3 independent of both EBS and of the instance that the EBS volume is attached to. And snapshots are incremental, so only blocks that have changed since your most recent snapshot are saved. When you delete a snapshot, data exclusive to that specific snapshot is removed, but data which is required for subsequent snapshots in the lifecycle is not removed. They can be shared across AWS accounts, and they can be copied across regions. There is an option to encrypt EBS volumes, and if you do this, data stored at rest on the volume, disk I/O, and snapshots created from the volume will all be encrypted. The encryption occurs on the servers that host Amazon EC2 instances, and this provides for encryption of data in transit from EC2 instances to the EBS storage. And there are a couple of different options for key management. It uses the AWS key management service master keys by default, unless you select a customer master key. If you create your own CMK, your own customer master key, you store that in the AWS KMS service, and you then have the ability to create, rotate, disable that key, define access controls, and audit access to that encryption key as part of KMS. So it's a very good and strong service if you have a requirement to demonstrate key control as part of a compliance standard that you may have to adhere to. This is relatively new functionality and features that have been provided through the launch of the AWS Key Management Service. We've recently also enhanced EBS volumes to provide additional capacity and additional performance. General purpose SSD now supports volumes of up to 16 terabyte in size with 10,000 IOPS at burst and up to 160 megabytes of throughput per volume. And then the provisioned IOPS volumes also on SSD, again the 16 terabytes in size, 20,000 IOPS, and double the throughput up to 320 megabytes per second. Next thing I want to show you is a quick demo of working with EC2 storage with EBS in the console. So let's jump over now and take a look at that. You can see we're back in the EC2 console here, looking at those three instances that we created for the earlier segment of this demo. And we're going to have a look now at storage with EBS, the Elastic Block Store. So if we go to the EBS section of the navigation panel here and click volumes, you'll see that we already have three 8 gigabyte volumes, one which is attached to each of the instances that we created earlier, and you can see the attachment information down here in the bottom. So if we tab across these different instances, you can see the attachments down there. Creating a new volume is as simple as just clicking the new volume button here, selecting the volume type that you want. So we'll have a 250 gigabyte general purpose SSD volume, checking that it's in the right availability zone, because EBS volumes are AZ specific, so you can only attach them to instances in the same availability zone. And we're not going to encrypt this volume, so we'll just click create. and that will result in the creation of that brand new 250 gigabyte volume for us that you can see here. And then we'll create a second volume. This one we're going to have provisioned IOPS, a little bit larger at 500 gigs. We'll have 7,500 IOPS for this volume. Again, it's in the right availability zone for us, and we'll turn on encryption. But because we have not already created a key in the KMS service, in the key management service, you'll see we only have the default EBS encryption master key available to us. So we'll use that, and that will then create that volume for us. You can see that our first volume, the 250 gigabyte volume, has already been created. If we wish to attach that to an instance, it's as simple as just right-clicking on it and selecting Attach Volume, and then the instance names that are available to us appear in this drop down. We will have 95D71, and it's that simple. In a second that volume will be attached to the host. It only takes a second or two to attach the volume, and there you are. You can see that we've successfully attached that volume to I95D7195C, which is one of the instances that we created a moment ago, cross-referenced here. And it's really that simple to work with storage in the EC2 console. Next thing we're going to take a look at is EC2 networking using the VPC, the virtual private cloud feature. There's a lot of documentation on VPC at awsamazon.com/VPC. VPC allows you to create a virtual network in your own logical isolated area within the AWS cloud, and you can place into this virtual network infrastructure platform and application services. And if you do that, those will share a common security interconnection framework. There's actually many different sub-features within VPC. ENI, which are elastic network interfaces that you can attach to EC2 instances to get persistent IP addresses that you might use as service endpoints. For example, game servers are quite a good use case for that. Subnets, where you can lay out a topology of your VPC and split it up into separate subnets. Network access control lists that allow you to control traffic flows to subnets and from subnets. Route tables to control the flow of traffic in and out and around your VPC. Internet gateways for similar function for internet accessible for internet access, virtual private gateways for building connectivity out of your VPC over a VPN to a corporate network or another data center, and Route 53 private hosted zones, which are private DNS hosted zones within your VPC. So a lot of features that you can use there to effect control of your network topology and layout. VPC itself can span multiple AZs, but each subnet must reside within exactly one availability zone. So you'd use at least 2 subnets in different AZs for each layer of your network in order to build a multi-AZ architecture, enabling you to tolerate failure more effectively. You have control over subnets and routing tables, and you can lay out your network in a topology which suits your use case. It might be a very simple approach with 2 public subnets where you're going to distribute EC2 instance across 2 AZs and put them in different subnets. Could be something more complex, public subnets, private subnets, VPN routing. Or it might be sharing services across a variety of different customers using VPN-style hubbing, where you've got services in the cloud hubbed across a number of different VPNs. To simplify this, we provide something called a VPC wizard that has 4 different usage scenarios that you can see on the left-hand side of the picture on this slide. And you can use those to quickly and easily create VPCs with common layouts, single public subnet, public and private subnets, and some more complex layouts that include private subnets and VPN access as well. So take a look at that if you want to create a VPC, but you don't want to deal with the plumbing involved in building that yourself. If you do want to exercise full configuration control over your VPC, a common way to do that is to use AWS CloudFormation, which is a templating language allowing you to describe AWS resources as code in a JSON format template, run that through the CloudFormation engine, then have those services created for you by CloudFormation. It's common for customers to use this as a mechanism for defining VPCs and exercising configuration control over them. If you want more information about that, aws.amazon.com/CloudFormation. You can find out more there. Also have a masterclass webinar from earlier this year where we covered this topic in a lot of detail. It's possible to peer VPCs. So this is a one-to-one connection between 2 different VPCs, either 2 that you own or a VPC that you own and a VPC that might be owned by a third party. There's a process for that where the requestor, the VPC that wants to make the peering request, sends a request to the other party, and that other party then has to accept that request, at which point that VPC peering connection will be created and those VPCs can begin to exchange traffic. Obviously, it's important that address blocks do not overlap in order to enable you to do that. More details at the URL that you can see at the bottom of the slide here, and several different topologies that you can use there depending on what your use case is. And then we recently added something called Classic Link. This allows you to, if you've been a long-term user of Amazon EC2, and you have EC2 Classic instances which are not in VPCs but use a different networking model. Classic Link allows those instances in the Classic networking model to take advantage of services within VPCs. You enable this on a per VPC basis, and then that will enable private communication between Classic EC2 instances and those VPC-based resources. And you can find out more about that if you check out the blog post, which you can find referenced at the URL at the bottom of this page. Elastic load balancing. So this is a very powerful service to enable you to distribute balanced traffic across a fleet of EC2 instances. It has some advanced features like timeout configuration, connection draining, and cross-zone load balancing. I think the best way to show this is through a quick demo where we're going to create an ELB and put it in front of those EC2 instances that we created a few minutes ago. So let's jump over now into the console for a quick demo of creating an elastic load balancer that can distribute traffic across a fleet of EC2 instances. In the EC2 console, we're in the load balancer section of the network and security navigation now on the left hand side. And creating a load balancer is simple as just hitting the create load balancer button, and then we'll be asked to define our load balancer, give it a name. Creating it inside our default VPC. We're going to be listening for traffic on the HTTP protocol only, and then we're going to assign a security group reusing that HTTP access group, which will allow traffic on port 80 to access our load balancer. We do not have a secure listener because we're not running a secure web server on our fleet of instances, and we're going to be pinging the index.php page. That's the name of the root document on the 3 web servers that we set up earlier. And we're going to add those EC2 instances to our load balancer just by selecting them here. Setting a name. Once again asked to review and create. Then when we hit create, you'll see that our load balancer is being created. We're warned that it will take a few minutes for our instances to become active in the new load balancer. And if we hit close at that point, you can see you've got information about the load balancer here. Our instances are here, and it will take a few minutes for those instances to become active. So I'm going to speed the video up at this point, and we'll return in a second when those instances have been registered, demonstrate to you that that load balancer has been successfully created. You can see there that our 3 instances are now in service, and if we visit the endpoint address that's been allocated to this particular load balancer, which you can see here in a new tab in our browser, you'll see that our endpoint is now available. And if we reload this, just enlarge the size of this text, if you watch the instance ID here, you can see that instance ID rotates around the different instances that were in our group because our traffic is indeed being balanced across those instances. And that's how simple it is to create a load balancer using the ELB service. Just clean that down. That's it. Next thing we're going to cover is monitoring metrics and logs. I'm going to move a bit more quickly now, we've not got a lot of time left. So Amazon CloudWatch is a monitoring service for cloud resources and applications that you run on AWS. It allows you to collect and track metrics, collect and monitor log files, and set and respond to alarms. And you can use Amazon CloudWatch to gain system-wide visibility into resource utilization, application performance, and operational health. And most importantly, you can use those insights to react. And the way in which you can react, it's enabled really because Amazon CloudWatch monitors resources and the applications you run in real time, and it can, when generating alarms, send notifications or automatically make changes to the resources that you're monitoring on the basis of rules that you're defining. For example, you could monitor CPU usage or disk read and write of EC2 instances, and then use that data to determine whether you should launch additional instances to handle increased load through an auto-scaling action. You can also use it in other use cases, which we'll touch upon in a moment, to take actions in response to alarms. There's integration between CloudWatch metrics and the EC2 console. You can actually see CloudWatch metrics and alarms for your instances directly within the EC2 console without leaving it. Here you can see some examples in my personal account of metrics that are coming off instances that I've been running there for some time. And it's very simple to access those metrics inside the console. There's a variety of monitoring scripts for EC2 instances, because what you're seeing there in the prior slide is information collected from the hypervisor and other infrastructure that AWS manages. Obviously, we don't manage operating systems on your behalf. That's something that you do under our shared responsibility model. But you may want to post metrics from your operating system, for example, memory usage, into CloudWatch so that you can view it alongside those other metrics in the console. We made available some code samples in the form of scripts so you can see how to do this, and of course you can write your own scripting or develop your own software to improve, enhance monitoring for your particular applications. But it's very simple to post custom metrics into CloudWatch and treat those like you would any other metric. Also recently announced an additional service called CloudWatch Logs that allows you to use log data to monitor applications and systems. It's stored in very durable storage. You can set retention periods, and you can access those log files via the web interface, the console, the CLI, or an SDK. We support Amazon EC2, AWS Lambda, which is a service for event-driven execution of JavaScript or Java code inside the AWS cloud, and several other services as well. So that's a mechanism for log management. And the combination of these two things, really, metrics management and log management, allows you to take action in two ways. You can respond to metrics with alarms and actions. You can also respond to log filters to create metrics and then trigger alarms and then take action. So you can drive actions directly from CloudWatch logs as well as driving them directly from metrics. And the alarm actions can take a variety of different forms. Simple notification service notifications, which you may consume or use for a variety of other actions. Auto-scaling actions, which we're going to talk about later in the session. And EC2 actions, which are simple things like recover, stop, or terminate instances on the basis of action. So, for example, you could terminate or stop idle instances after a certain period of inactivity. Or you could recover an instance in combination with status checks to automate instance recovery in the event of an instance hang or crash. So you've got several different options there for taking simple actions with EC2 that you can use as part of an availability or cost optimization strategy. Security and access control, two components here. Access credentials, these are the API credentials, the access and secret key that you use when accessing AWS APIs. Then there are key pairs, public and private keys used to authenticate when accessing EC2 instances via SSH on the Linux platform, or for decryption of administrator passwords on the Windows platform. You can also use IAM roles to pass access credentials to an instance, enabling your instances to work directly with the AWS APIs without having to store credentials on the systems, on the instances themselves, or worry about credential rotation. I'm just going to give you a very quick demo of how you can use this feature in combination with a service like S3 to authorize an instance to perform certain actions with an AWS API. So a very quick demo using IAM roles with EC2. I'm back in the EC2 console here, and for this demo I'm actually going to launch another instance in just a second. But before I do that, I'm going to jump into IAM, the IAM console for identity and access management, and create a role that I can assign to the new instance that I'm about to create. So I'm going to access my IAM console, and I'm going to take a look at my roles here. You can see I've got a couple of system roles that are already in place, but I want to create a new role. Call this new EC2 role. And I'm going to make it possible for EC2 instances that are using this role to work with the Amazon S3 API, but only the Amazon S3 API. So we're going to allow our EC2 instance to call AWS services on our behalf. So it's an EC2 instance role that we're creating. And I'm going to attach the Amazon S3 full access managed policy to my role, which is a policy that will enable my instance to do anything within my account with the S3 API. And that's it really. I created that role, and I've now attached, as you can see here, I've got that policy attached to this specific IAM role that I've just created. And the next thing that I'm going to do is launch another EC2 instance that carries this role. So if I go to EC2 once more, launch an instance. I can leave pretty much everything the same as I did previously. I don't need bootstrapping data this time around because I'm not going to be bootstrapping this instance, but I am going to assign my new EC2 role to this instance. Then I'm going to review and launch. And in the case of this instance, I do want SSH access. So I'm going to use this automatically created security group that's going to give me SSH access to this particular instance. And I'm going to use my US1 key pair. Okay, so we'll allow this instance to launch. I view my instances. The console will show my new instance launching right here. I forgot to add a tag, so let's do that with inline editing. While my instance launches, just wait a second or two and this instance will launch. While that happens, we'll prep our console command ready to log into this instance so I can show you use of that role. So I have a terminal window here. I need my instance public DNS name, which is not actually available to me yet. Here we are. So it's this public DNS name that I need from here. Back to my terminal. And what I'm going to do now is log into the instance that I've created using SSH, using the key pair that I had earlier. And I'm using a username here, EC2 user, which is the default username for instances created from the Amazon Linux army. You can see that I'll be logged into that instance now. So this instance has been up just a couple of minutes. And I want to just show you that I have permission here to access the S3 API. And I can do that using the list buckets command. This shows all of the buckets created in my S3 account. You can see that I just have one enm-aws-demo bucket. Conversely, I do not have permission to access other AWS APIs. So we'll go for the describe instances API, the EC2 API. I need a region for this. And you'll see that I get an unauthorized operation there because I don't have API or access permission for that particular API with my credentials. If I jump back onto the IAM console, I'm going to strip myself of the role, or rather remove the policy from the role that I created. So we're back looking at that new EC2 role. We'll detach that Amazon S3 full access policy from that role. So that role now has no policies attached to it, and the default obviously is no access. And if I jump back onto my terminal and repeat that command, you'll see that I no longer have permission to perform that list buckets operation. I hope that shows how you can control the permissions that are available to an AWS EC2 instance to work with the AWS APIs by using IAM instance roles. Okay, we're going to finish up today's session now by talking about deployment and cost optimization. And the basic premise for deployment on EC2 is that if you need to SSH into your instance or connect to your instance in some other way, your deployment process is broken. It's a slightly glib statement, but what we're saying here really is it's ideal to treat EC2 instances as immutable components, and one of the ways to do that is to use Amazon machine images, so armies, the base images from which new instances are created, as a mechanism for deployment. And there are three different types: Amazon maintained, a set of Windows and Linux instances kept up to date by Amazon in each region; community maintained, which are images published by other AWS users and shared through the marketplace or through other techniques such as giving image IDs to other parties; and your machine images, so armies that you can create yourself from EC2 instances. You can keep those private or you can share them with other accounts, effectively creating your own community armies. And there's a continuum here really for deployment. At one end of it is baking an army, which is a fully ready to go machine image with all of your software instance fully configured, and you just start a new army when you want to start a new instance, through to dynamic configuration, which is using services such as the Instance Metadata service, user data, and Cloud Init to perform actions on instances when they start. And you can combine these two things, of course. I painted it as a rather black and white picture there, but you could combine them together using base images with custom initialization scripts, which could be your golden base, and then using bootstrapping with that to pull in custom information and perform post-launch tasks like pulling in code from source code repositories, GitHub or others. So you've got this continuum that you can land upon. At one end of it is more heavyweight configuration and a faster startup time, combined with a degree of static config and therefore less opportunity to change. And at the other end, continuous deployment, the latest code, environment specific, but it takes longer to do that dynamic configuration on instance startup time, which means going too far along that continuum to the right might not be the best option when you want to combine that with auto scaling. Now, auto scaling is a mechanism for doing two things: maintaining EC2 instance availability, in other words, keeping your fleet at a predefined size, or automatically scaling your EC2 fleet, following the demand curve for your applications in response to metrics, typically metrics from CloudWatch, although you can also use other sources for those metrics and triggers. And what you have here is reusable instance templates combined with automated provisioning and adjustable capacity. And when creating an auto-scaling group, three things are required: a launch configuration, which defines what auto-scaling will create when adding instances. It's a one-to-one mapping, one launch configuration per auto-scaling group at a single time. And as an example of a command line there, command line execution for creating a launch config. Then you have your group, an auto-scaling managed grouping of EC2 instance, which automatically scales the number of instances according to policy. And you can see an example command line for creating an auto-scaling group there on the right. And then you have your policy, which are the parameters for driving the up-down scaling action. It's typically CloudWatch alarms, can be triggered by external sources as well, where you might drive your own scaling actions in response to something external. Maybe it's the weather that you're using to increase the amount of instances if you run a journey planner in the rail industry, or you're running some other weather critical service. So you can use external metrics as well. Granularity is an important factor here. Consider this hypothetical workload profile. You can address that in several different ways to cover the profile of CPU usage across the day. You could have 41 instance hours of an M3 large, which would cost you $6.31 per day and scale like this. Or you could have 70 instance hours of a T2 small, cost you $1.96, because the scaling is more granular and the units themselves are slightly more cost effective, lower cost because they don't have quite the CPU performance. So you could consider that an opportunity for a pretty significant saving. So I would say evaluate carefully what instance size you're going to use to fit the profile of your workload. And you can experiment with it, of course, tweaking your launch config, tweaking your auto-scaling group over time. We recently added more responsive scaling policies, which enable you to increase the number of EC2 instances that you add if your thresholds are breached by different levels, effectively setting threshold bands and specifying the number of EC2 instances that are added if an alarm is hit in those bands. And with this step policies model, the alarms are continuously evaluated during a scaling activity and while unhealthy instances are being replaced. So let's say CPU load increases and the first step in the policy is allocated, but during the warm-up period, the second threshold is triggered. In this scenario, auto-scaling will look at both policies and choose the one that has the highest magnitude. So it's a good way to help you respond to changes in demand more rapidly and more aggressively if you need to do so. There's a comprehensive blog post on that from Jeff that you can find at the bottom of the page. Other deployment options, not got time to cover everything, but two that are interesting, very interesting. AWS Code Deploy, agent-based deployment of software onto large fleets of EC2 instances. We have a Code Deploy agent that is deployed onto the instances, a small package for Linux and Windows. It reads a YAML deploy spec file, or app spec file, which contains deployment info, and that will then execute deployment hooks, place artifacts or assets onto the file system in locations that you specify, and then execute further deployment hooks, enabling you to do smart deployment. It's aware of things like availability zones, works with auto scaling. So that's a very good tool that you can use for code deployment onto EC2 instances once they're running and they have the agent installed, policy controlled by IAM. And additionally, the Amazon EC2 container service. So if you're deploying containerized workloads in Docker, this could be a good solution for you. Highly scalable, high-performance container management service allows you to really simplify the process of launching and scheduling large numbers of Docker containers on a substrate, an underlying foundational layer of container instances running on Amazon EC2. And this is a service that will continue to evolve quite quickly. Just the day before yesterday, we had a post from Jeff Barr about how we have added new features to this over the first half of the year. Things like additional regional support, support for a long-running service scheduler, load balancing support, console support, CloudTrail integration. Quite recently, we announced at DockerCon in San Francisco that we're going to add support for Docker Compose and Docker Swarm in the near future as well. So if you're interested in running Docker on AWS, aws.amazon.com/ECS. You can find out more about that there. Run today, so I'd like to apologise for that. Before we wrap up, let's just look at cost optimization with EC2. It's basically 3 different options that you have for cost optimizing your purchasing of EC2 instance. The on-demand, which is the familiar compute capacity by the hour with no long-term commitments or upfront payments. That's the default when you launch an instance. Then you have reserved instances and spot, which we'll focus on quickly now. You find out more about those 3 options if you check out the purchasing options page at the bottom of this slide. Getting started with reserved instances. This is pre-reserving EC2 capacity to optimize your costs over time. There's a comprehensive guide to this on the AWS website, which you can find at the URL at the bottom of this slide. But savings of upwards of 60 to 70% are available to you if you choose to reserve your EC2 capacity for a 1 or 3 year period. And you can use EC2 usage reports or AWS Trusted Advisor, which is a feature of our business level premium support service and above, to identify opportunities that you might have to reduce your costs with reserved instances. So check out those resources if you're running long-lived workloads on the EC2 platform. Don't miss an opportunity to save yourself money. Spot instances. This is spare Amazon EC2 instances that you can bid on where the price fluctuates in real time based on supply and demand. It's integrated with the console, so you may have noticed when I launched my first instances earlier, which I showed you, I could request spot instances at that point. If I'd done so, I would have been asked to place a bid price. If my bid price had been higher than the current minimum, or current market price rather, I would have been allocated the instances then. If it had been lower, my request would have been put in a queue and would basically wait there until the price fell to a point at which my bid exceeded the market price. That's how the model works. And there's quite a few third-party and AWS tools that are integrated with spot price bidding. It's used across a wide variety of different use cases: analytics, big data, financial modeling, geospatial, and others. You can find much more details, once again, if you check out the URL at the bottom of this slide. Some resources where you can learn more. Obviously, the most important and primary resource is the EC2 product detail page. There's also several good getting started guides, a getting started with EC2 guide, and also an excellent guide on getting started with auto scaling, which includes the new feature that I talked about earlier for accelerated scaling under heavy load or situations where metrics exceed 1 or more thresholds. So that's something that's worth checking out. If you want to build your AWS skills more generally, please check out our training and certification offerings. And that concludes everything that we have for you today. We're not going to have time for questions because we've overrun. I'm very sorry about taking up more of your time than we said we would. There's so much content to do with EC2, as I hope you appreciate. It's very difficult to get it all in an hour. If you want to stay up to date with us on social media, you can find me and AWS at the Twitter accounts that you can see here. And of course, if you do have any questions, any things that you feel we haven't covered during today's session, we're going to leave this webinar open in the Q&A mode that we'll switch to now. Please leave us a rating, and please also let us have your questions, and we will come back to you in email over the course of the next few days. Thanks very much for giving us a bit of your time to learn a little bit more about AWS, and we hope to see you on another webinar very, very soon. Thank you. Bye-bye.